Hello. Good afternoon. I think we should start now. I'm Victor Żołnierski. I will tell you who I am soon. But how many of you seen this topic before? Is there anyone? I've been here 2 months ago and showed this presentation. Well, okay, because this presentation is different than the previous one. Not all is different, but some things is different. I'm sorry for my English. I'm still trying to improve it, but it's hard. It's probably some of you know. But I'm working on it, and I will be happy for any feedback from you after this presentation. Okay, who am I? First of all, I'm a troublemaker. Yeah, I am. I'm a troublemaker. I'm doing a lot of troubles. And I'm an agile coach working for Code Sprinters, coaching company from Poland. We are helping organization in agile transformation. And we're coaching team, organization, personal coaching. Also, we are leading some trainings and courses. I'm also passionate. Everything what I'm doing with passion. And it was the same with agile coaching. I started as a software tester. A few years ago, I started as a software tester. I was manually clicking. I know it's funny. How many of you are testers? Manual testers. Oh, no, I feel that. Right. It was pretty funny, but pretty boring. And after some time, because I have been doing this with passion, I discovered that I could improve my work. I started to figuring out what this testing is about. And I figured out that it's not about the testing itself, but it's about the quality. By the testing, I cannot assure quality in the software. It's much more complex. Then I thought, okay, so maybe I should start to learn how to program, how to do programming. And I started programming. I learned Java, I learned PHP, Ruby on Rails, and Python, as far as I remember. And I started to automate tests. But it wasn't enough, still. Still, I knew that the test automation, it's not enough to assure quality. There is something more. Then I discovered something like Agile. This is some kind of Agile conference. I know XP, Agile. It's pretty the same. The purpose is pretty the same. When I started learning what the Agile is, I changed my job to the pure Agile company, pure Scrum company. Then I met a lot of Agile enthusiasts, a lot of Agile people, and they teach me that it's not about the process which we are using. It's not about the Agile. It's not about the Scrum. It's not about the pair programming or test running or about development. It's more about the people. So it was the reason why I started after some time, after a few years of learning and working with other people, I started Agile coaching. Because I believe that people are the most important part of the system, of the organization, if we are thinking about the quality. And the quality is very important. And this talk will be about the reversed test pyramid. It's one of the ways how we could deal with legacy code. Okay, can you imagine perfect software? I expected from you that, I know it's after lunch and you are all tired and a little bit sleepy, but I expected from you some actions. So, can you imagine perfect software? What is the perfect software?
There is no need to maintain.
There's no need to maintenance, okay. No need to maintenance. Maintain. What else? What?
No bug.
No bugs.
Happy users.
Bugs, many tests. 100% coverage. Happy users. The scripted code. Happy developers.
Money.
Money, always.
Solve real problem.
What?
Solve real problem.
Solve your problem, yeah? Solve problems. Models. I know that you can't read it. It's not the point. So, how could you describe the perfect software? What else? On the long run?
Customers are satisfied.
What?
Customers are satisfied.
Yeah, customers, happy customers, I know that you can't read. What else?
Well, it's do what it's supposed to do.
It's do what it's supposed to do. Do what it's supposed to.
New feature come easy, no problems with the implementation.
New feature are easy to implement.
No redundant code.
No redundant code.
It fits into the given resources and problems.
It fits into given resources. Okay. I don't know how to write it down. There's no place. What else? Any ideas? Very good. You know what the perfect software is. Some time ago, about half a year ago, do you know this guy? How many of you know him? Yeah, it's Uncle Bob, of course. The picture is the best one. It's my favorite. This guy had been in Poland, I'm from Poland, and he had been in Krakow at some conference half a year ago, more than half a year ago, and he was talking about the perfect software. He said something that perfect software is the software where you don't have any functionality implemented in your view and in your database model, data model. All the functionality need to be somewhere between the view and the model. If you are talking about the model view controller, so it should be controller. He said that you don't have to have any end-to-end test for your software. Get rid of all of your end-to-end tests. You don't have so much integration or functional tests. All what you need to have is unit tests. Could you agree with it? No. Me too. It's pretty difficult to build a software like this. It's possible. It's really possible to do this. I've seen few examples of that. I've seen few systems which are tested in that way that there are only few end-to-end acceptance tests, some amount of functional integration tests, and a lot of unit tests, and it's for enough, and there are no manual testers at all. It doesn't mean that there is no manual testing, but there are no manual testers. In some examples, these are the critical systems, so it needs to be tested, really tested. It's possible, but it's easy to write the software if you are writing software from scratch and know this testing pyramid. If you know this testing pyramid and you are developing your architecture that way that it should be testable by unit test, some amount of functional integration test, and as low as possible end-to-end test, it's possible to do this. It's pretty difficult to do this in the existing code. It would be perfect to work with perfect software. Perfect to work every day. How many of you are working with perfect software every day? One?
There's no need to work at all.
There is always some work to add new feature. It's pretty easy. Some work down there.
Where you can apply your brain, it's very easy.
It's not challenging, yes. No, it still can be challenging because, yeah, it's very important what you said. Sometimes we are focusing on the problems with how to implement something, but not the problems, real problems which we need to solve. And I'm not sure that this is the correct way how the programming should look like. We need to focus on the real problems. There was somewhere there where the perfect software is solving real problems. We need to focus on these problems, but not on the problems which are just technical problems or problems of legacy code. It would be perfect to work with perfect software every day, but reality is different, unfortunately. We are dealing with legacy code. Do you know this term? You hear it? Well, of course, everyone here. How many of you works with legacy code every day? Yeah, almost all. Yeah, unfortunately, yeah, me too. This is what we are dealing with every day. What is the legacy code? I guess there is a lot of stories around the legacy code. You could say that it's probably the code which you cannot understand when you are looking at it. For example, this is the code which, if you change something in one part of the code, there is some amount of bugs introduced in the another part of the system. This is the code which is not tested, for example. This is the code which is, I don't know, unreadable. People who wrote this code are not with us anymore. Nobody knows anything. There is no documentation, specification, etc. There are some low quality code patterns like, I don't know, naming variables as A or something like this, etc. There are no separated modules or units. Everything is connected to each other. This is the legacy code, and we are dealing with it. But how did we get to this point? You know what the perfect software is. You are the developers, yes, and you know what the perfect software is. But we are dealing with legacy code. How did we get to this point? How did it happen?
It was before me.
It was before me, but after you, there will be someone else who said that it was before me. So how did we get to this point? We know what the perfect software is. We probably know how to build the, maybe not perfect, but almost perfect software. But we're still producing legacy code. Technical debt, yes, I will be talking about it. And yeah, time pressure, deadlines. Who is responsible for legacy code? The guys before us, okay. Yeah. Legacy developers. I need to put this in my resume. I am a legacy developer. Yes, there are probably, I don't know, managers, testers, analytics, agile coaches, developers who are legacy developers who are responsible for legacy code. I think it's all about the money. Money is the main, is the why we are producing the legacy code. But from the other point of view, there are a lot of open source projects without any money, which are also legacy. I was thinking a lot about how did it happen, and even if you are trying the best how we can to produce the perfect software, at the end it will become legacy. Someone shared with me the definition of the legacy code, that this is the code which you wrote 1 week ago. And it is legacy right now. Because you know more, you know how to do this better probably, or maybe not, but you will know sooner or later. I will give you an example. About 3 or 4 years ago we started working on our Scrum tool, it's called Banana Scrum. And we developed it with all this XP practices like test-driven development, pair programming. We use continuous integration. We have about 100% of unit test code coverage. We have almost 100 functionality covered by web tools, so by the Selenium tests, and everything was great. But after 1 year of developing, we started development and started selling this product. And people buy it. There was some customer requests. We didn't put all of them to our software. Right now we are trying to, we stopped development for I don't know, 2 years, just maintenance, just critical things was fixed or introduced it, but right now we are trying to add new features, and we figure out that, fuck, it's legacy code. We do everything as by the book, but it's legacy code right now. We cannot introduce any change in this code. Every change which we need needs to be. We need to refactor a lot of functionality, or even rewrite it from scratch. A friend of mine said he saw this code. Who did this? Nobody uses libraries or tools or frameworks anymore. You should rewrite it from scratch. It was 3 years ago. 3 years ago, nobody cared about the Chrome browser. This Chrome browser was, I don't know, about 5% of the market. Right now, it's one of the most used browsers, but half of our functionality didn't work there. Our competitions grow. They develop their own tools. They have new ideas. It was Scrum tool. Scrum 3 or 4 years ago was pretty different than it is right now. So we need to update our software, but it's not so easy. Competitors are doing pretty well because they are continuously developing. Right now, we need to, I don't know what we need to do. We'll probably do that what I will be talking in the next half hour. So you will see. Okay, it's all about the technical debt, as someone said here. What is the technical debt? Did you hear it before? Right. Technical debt for that one who didn't hear it is this blue line. Yeah. Okay, this is the cost of adding new feature, one feature in the time. If we would add this feature at the beginning of our project, where it's greenfield project, when it's that there is no complexity, functionality is small, it's pretty easy to add it, and the costs are pretty low. During the time when we are increasing the scope, when we are implementing more and more features, this costs increase. This yellow line is the potential benefits from adding this feature. For example, I don't know, if we add something there, it will make some amount of money. Blue line cost of adding this feature. The technical debt is a situation where adding new feature is more costly than benefits. In many situations, a lot of companies still adding new feature to the project, which if they add this feature, will not make any benefits. And it's pretty sad, but I don't know why. People sometimes believe that, well, maybe something will change on the market, maybe people will really use it, maybe our predictions about the benefits are bad and there will be more benefits from that? Maybe. Maybe not. The red line is the cost of rewriting whole system from the scratch with this new feature. And to be honest, it's pretty close to the yellow line in most of the project. So, what happened here? What do you think? When people realize that benefits from adding new feature are lower than the cost of adding it.
They start to write it from scratch.
Oh. We prioritize the feature, yes, this is one of the, most of the people, especially managers, start to blaming others for that. Start to looking for guilties. And you know who is the guilty? You. How many managers are here? Yeah. Developers. I think most of you are developers, some kind of developers. Yes, and you are guilty for that, you know. No, not always. Okay, so at this point, after they start blaming, they try to figure out the solution. They force people to work over hours. They trying to move the deadline somewhere in the future. They trying to reprioritize the scope. They're trying to do a lot of other stuff, but it's too late for that. Especially they trying to force others to work over hours or hire new people You know what will happen if you are hiring new people for the project. Productivity is getting low, always. Doesn't matter how good this person is. The complexity of the solution of which these new people are introducing to the system is quite high because they are making a lot of duplication. It's probably not the way how we should develop perfect software. Some companies, especially startups, are smart, and at this point they are looking for something which is called venture capital. They are looking for some other company who could buy them. So they are focusing on the revenue, and because of that, the price of the company is getting higher, and they are selling it. There are some venture capitalists, companies which are focused on buying company, industries like business like this, projects like this, and they are smart at this point. They're hiring a lot of QAs who need to figure out how to deal with this legacy code. 1 per 10 projects which are bought by venture capital are successful, more or less. In some cases, technical debt is something which we really want. Could you give me an example? Prototyping, startups. Yeah. Prototyping. Okay, startups is I think it's a good example of prototyping also. Then, if we are doing startups, we need to go to the market with something new, something which we cannot predict if it will be, if we can sell it, because it's new. We don't have any other examples of this kind of business or this kind of product. So, in that situation, we are introducing technical debt by purpose. But unfortunately, temptation of easy making money and money making is huge. People forget about the quality. People live in the illusion that it's possible to continuously deliver or develop software. Do this fast without caring about the quality. And this is the reason why we get to this point where in some situation we need to sell our business or sell our company and start another one or rewrite from scratch. What is the success in the software development? For me, success is nothing which we could say that's continuous. You can achieve the success, but you can lose it very, very fast. Some time ago, before the internet, Web 2.0 era, it was pretty easy to be successful. We are creating agile project. We're creating IT project. We have some documentation, some specification. We develop it, put it in the box, put this box in the shop, and people will buy it or not. If they buy, it was successful. If not, well, shit happens. Right now, we need to forget about the term IT projects. We are not doing projects anymore. Project, by definition, is something which we can say that this is the start of the project and it will be the end of the project at this date. So it's a time period. There is some scope which starts here and here, and this is the project. Right now, we cannot say in most of the cases, we cannot say that we are dealing with IT projects. We are working on continuously developing software. We are maintaining software. As you said, the legacy code is something which you found when you get to the company, which is something which someone else before you done. So this is the truth, and most of the projects are just maintenance of the old systems. How many of you are working on greenfield new project which you are starting? 1, 2, 3, 4, 5, 6, 7, 100 people, and only 7 are working on new greenfield projects. Yes, projects. I still using the projects. but it's not a project anymore, I think. In some cases, probably it's still a project and it's usable folder. It's working. It works pretty nice. You could lose this success very fast because of the competition, because of the other businesses who could steal your idea and improve it. I read some papers about it, and they wrote down that it was Standish Group published this, and they wrote down that there is about 76% of industries which are just copying solutions from other industries. So, yeah, they are doing this, they are improving these copies and selling it better because they have more money for marketing, salesman's department, etc. Okay. We talked a little bit about the legacy code, about the systems, about the success in the software development, but how to deal with legacy code? Well,
so what was wrong with your project which you created in TDD? What kind of technical debt you have introduced so you do that?
it was more, I like to call it technological debt. Technology goes forwards, and for example, libraries which we used before are not maintained anymore. Because those open source libraries are there, and new libraries which are introduced. New libraries are not compatible with the old ones, so we cannot, for example, use fancy calendars or charts or etc. in our application. There is a lot of things. As I said, this our JavaScript library was slightly modified. I don't want to say that. Yeah, we did it. So it was jQuery, our implementation from some reason, and now it's not compatible with Chrome Chrome browser. It used to be not compatible, but right now we fix it. And there is a lot of other things like this. Okay. How could we deal with legacy code? I think we will talk about it later if there will be some time. Reverse test pyramid. It's one of the solutions which we figure out with my friends. Not only with my friends, but the people which I was telling about, for example, this story with our software and other projects which we are maintaining. And what is it about? Mostly it's, you need to write as much as possible end-to-end test. You need to write as much as possible functional and integration test. And you need to write as much as possible unit test. What? Yeah, it's too many tests. I just said that, yeah, you need to write a test. But it's not so easy. You cannot do unit testing if you don't have any units in your software. It's impossible. Legacy code is in many cases it's a software which doesn't have any units, doesn't have any separated modules. It's pretty difficult to test this module separately if there is no modules or units. You cannot do integration tests if there is nothing to integrate, if everyone is a huge piece of software. It's impossible to do integration testing. You need to refactor your code. Refactor, the goal of this refactorization is making your code more testable. But how to refactor without any tests? It's, you know what the refactoring without tests means. It means that we'll screw up. Sooner or later, we'll introduce new bugs in the software, or we break everything. We need to test. We have testers, yes, we have. And then, what the testing is about? What is the reason why we are testing software? Why we are making tests?
So that we ensure that it works properly.
Yeah.
And we can break anything with the refactoring or implementing new features and so on.
Agree. It's about giving a feedback about the software. Giving a feedback, is our software working properly or not? This is the purpose of the testing. It doesn't matter if it's manual testing or automated testing. The goal is to give a feedback to the developers that they didn't break anything. If this feedback loop is fast enough as a unit test, it's pretty easy to get it, and you always need to could run this test like in TDD, and you know what breaks the functionality. Okay, so how to refactor without testing? We start with this high-level test, with end-to-end tests. This is the yeah, I like this picture. This is the way how we start. We start with end-to-end tests. Why? Because if we cannot found any units in the test, we cannot test it as an integration. We just could do what the testers do, manual testers do often. We just could test our software as a black box, treat it as like as a black box. If you is there someone who done code retreat, legacy code retreats some time ago or something like this? Yeah, there is an example. This JB Rainsberg introduced this idea to write the characterization test at the beginning. The test which just treats your software as a black box. There is some input data and some output data. You take your old system, treat it as a testing oracle, put there some random input data, and look at the output. Save that output somewhere, save that input somewhere, and then you are starting to change this software step by step, and still running this test and trying to figure out if the output is changed somehow. If it's changed, it means that you broke something. You're assuming that software is working properly before your changes. We don't care if there are some bugs in this. If we have some time, I will tell you a story about some kind of refactorization like this. Now you can refactor your code. Now you can introduce some units into your code, into your system. Now you can test it by unit test. But there are some problems with end-to-end test. I like these pictures. It's pretty similar. End-to-end tests are too slow. They're taking a lot of time. You need to set up your whole application, especially in complex systems. You need to set up your database, you need to run your browser or another things. A lot of components of the systems and a lot of third-party systems. And it takes a lot of time to run this test. As I said, testing is about giving a feedback. This feedback loop should be fast enough. What does it mean fast enough? For me, it's, I don't know, 15 seconds, 20 seconds. This is the feedback which I am expecting from the test. I change something, I run the test, 20 seconds is far enough that I will still keep focused on what I was doing. It will be longer, I will probably go for coffee and forget what I have done. Another problem with end-to-end tests is maintenance of these tests. These tests are pretty difficult to maintain. And if we really need end-to-end testing on a software, it means that we break something in our architecture. That is something wrong with our software architecture. But yeah, we are dealing with legacy code, so yes, there is something wrong with our architecture. To be honest, this whole idea of reverse test pyramid is about the reversing this pyramid back to the normal shape, where we have only a few of the end-to-end tests, some functional and integration tests, and as much as possible unit tests. And how to do this? I don't know, because it's not any silver bullet. I've heard from some of you that there are some tools which could be helpful. Yes, probably for some class of the projects that they could be helpful. From my experience, in most cases we wrote the frameworks for testing like this by ourselves. We cannot find any tools which could be helpful.
What is the problem? So if you use refactoring and you have created several units. Now we can start
Right.
creating unit
Yeah.
tests. Then we start first.
Yeah. We are introducing new architecture step by step. We factor more. If we have some units, we could separate another units. We could, I don't know if you're familiar with domain-driven design. This is mostly also about it. You separate your domain and try to keep your domain clean, and everything else could be a mess, but you need to keep your domain clean. Then you can find another domain or extend your domain to other class of application, and that way you are changing the architecture of the application in some kind of step by step. You need to remember that reversing this test pyramid will take some time, and the cost will be pretty high, but you need to do this if you want to pay technical debt. Or do something else, but you can do this. Okay, we have about 30 minutes. I have a few final thoughts. First of all, keep your technical debt as low as possible all the time. It's much more cheaper than paying it back later. You can use your slack time. You know the idea of the slack time? How many of you are using Kanban? One, two, three, okay. Scrum? Both in Kanban and Scrum there is this idea of the slack time. Slack time is a time which is probably could be considered as a time of the wasteful time. You are, for example, at the end of the sprint, you have some time when you are waiting for the sprint review meeting. In some cases, you are trying to fix the bugs the time or doing something else, but according to the Scrum, you need to be prepared the day before or even earlier to the review. So you have some time. There is no new feature, no new user stories which you can implement during this time. So this is your slack time. You can use it, I don't know, for example, for learning. You can use it for fixing bug, or you can use it for refactoring or paying back the technical debt somehow. In Kanban, you have week limit, work in progress limit. It's pretty the same. In some situation, you have fill up this columns in the Kanban board, and there is someone who are not working on anything because of the week limit. If the week limit is aggressive. And in this situation, he or she could focus on the paying back the technical debt or building some new tools, frameworks, or other improvements. Before you start doing this reversing test pyramid, you need to remember why we are doing this. We need to remember that we want to reverse this test pyramid back. We want to pay the technical debt. Little better than found. Did you hear it before? And it's in Clean Code, one of the first pages. Some people asked me when I was giving this presentation before, where they should start with refactoring, where they should start with this reversing test pyramids. They cannot test whole system. Yes, they cannot. We cannot do this for all the systems. I think that the best approach is doing step by step. Every time when we are doing something with our code, when we are changing, we need to leave the environment better than it was before. Before we start of the refactoring or before we start of adding new feature, we should refactor everything that is around our new feature. Prepare our environment to work with it. Beware of the refactoring just for refactoring. Nobody allows you to do the refactoring just for refactoring. How many of you have been using this, or have started refactoring projects? We are doing something, we know this legacy code, so now we are shouting, oh no, this 2 weeks we need to spend on the refactoring. How many do this? How many do this? How does that end up?
Yeah, but we didn't finish it because our customer.
Our customers changed their mind.
It was business problem, so it was not our fault, but
Yeah. It is always business problem. That's what I say about the success. If you want to be successful, if you want to achieve a success and keep be successful, you need to add value all the time. You change something all the time. You cannot allow developers to just doing refactoring. We know that there is value behind that because in the future we need to add, we could add more features or do this faster. But from the customer's point of view or our users' point of view, there is no changes in the software. So. Yeah, but during the time other developers change everything and you need to add these changes to your refactored project, and then merging of these two projects was nightmare. No?
In the same branch, so
okay.
Okay. Actually it was quite a successful project.
Okay, I can congratulate you, but in most of the cases which I've seen, it was a problem to do this. And as I said, it's difficult from the business point of view to allow developers to do refactoring just for refactoring. The biggest question from the business is, what? You need to improve the quality of your code? So why didn't you write it at the beginning in the high quality? I don't get it. Resist temptation of the rewriting system. History is against it. I don't know if you read Death March book. And yeah, read it. I will be not talking about it, but I've seen it a few times. I've even participated in a project of it wasn't rewriting, but just changing database from one to another. And no, it always end up with the new project, new software, which is pretty the same as that what we created before, just because. I don't know why. My idea right now, if someone will ask me, okay, so what we can do, I would say just outsource it. Just give a chance to another company, another group of people which are not connected with your company, with your business, with your culture. Maybe they will do this better, maybe. And don't let them look at the code which was there before. And during this time, don't introduce any changes to the old system. We need some stabilization to do rewriting. But I'm not sure that is there any business which could could agree to do this. And the most important part of this presentation, remember to always remove your duplicated tests. We are doing this reverse test pyramid just to reverse it back to the normal shape. We don't have to have this end-to-end test. We are refactoring just because we want to introduce new infrastructure. Some people ask me, okay, but we spent a lot of time on this writing end-to-end tests. We do a lot of functional testing. We then use this unit test. So if we have this end-to-end test, maybe we didn't remove them, but maybe archive somewhere or just run them once per week. No. If you are assuming that you will need this test in the future, you are doing something wrong. From the beginning, you are doing something wrong. You need to remember to remove this test. You need to refactor your architecture in that way that it will be testable on the lower level. You need to refactor it in that way that it will be testable on the lower level. Also, if you even want to run this test one per week, it will still need to be maintained. It's hard to maintain this test, and you will waste a lot of time to maintaining end-to-end testing. Also, if you will not maintain it, you will have some false positive or false negative safety net. What is the safety net? Safety net is something which prevents us from introducing new bugs in the software and pushing it to the production. False positive or false negative safety net is even worse than lack of the safety net. And last, in my opinion, software quality could be understood as a ability to introduce new changes into software, continuous ability to use new changes. I think that right now, according to this, what I said about the success in the IT business, this is the most important part of our software. It doesn't matter if it's the code quality, it's the tools which we are using, procedures, process, etc. All what we want to achieve is to introducing new changes into software all the time with low technical depth and with stable pace of running it. Okay, questions? Okay, so I will tell you a story about, I will give you an example of how we do this reverse ground for one of our customers. This customer was some development company from UK, and they create some accountment system for reporting. And the problem was that they use PHP 4 or something like this, I don't remember. And they didn't have any tests. Right now they didn't know anything how should it work. If there was some, I don't know, 10 or 12 reports generated from some data. They don't know what are the numbers in this data, there are no documentation, and there is no one who could tell us what the software should do. And they said, okay, we need to add new features, but right now we have no idea how to add new feature in this piece of software. What we do? We said, okay, we could try, but we need to start from refactoring it. They okay, we tried, but every time we do this, the customer complained that we broke something and he cannot even describe what we exactly break. But he said there is something broken, we need to revert back our version. Okay, so we prevented by this end-to-end test. We just wrote some framework for generating tests, generating some input data, and even not generating, we just put some real data from production from the system, put it into the system, and then we write a framework for saving there was tables, so every cell in the tables was saved in some kind of data file. And we're running this test all the time, just putting this input data and looking at the output data if they are the same. Problem was that it takes about 2 or 3 hours to input this data, to run this test. But it was the only way how we could refactor our code. And we do step-by-step refactoring. Every time we run the tests were running on the 3 or 5 nodes all the time. And we get a feedback from our automated test, how our changes works and do we introduce any new bugs or something like this. The most interesting part was that we discovered that if you are running this test on the few different machines, that the results are different. Then we discovered that there are dependencies from the processor architecture. There was 42 bits or 64 bits. There was difference in the calculations, and the results was pretty different. But it doesn't matter. But this was the way how we could refactor this system and introduce new features in it. Okay, are there any questions? We have 1 minute. 2 minutes. I'm not sure. I'm working on that, but still working. But I could recommend you working with Legacy Code book. You read it. So this is one of the book which understands something similar. There is few blogs about it. Also, this Jake Rainsberg wrote a lot of notes about it. J.B. Rainsberg. He was specialist in the Legacy Code. Okay, any other question? Yeah? I'm not explaining to the customers. I'm not explaining to the customers. Good example, if you are going to surgery you ask your doctor how he will be operating or doing something? No, you just want to be healed, yeah? And this is the same way. I don't have to explain to customers how I will work with our technical skill. Yeah, just doing the estimation, I'm figuring out, okay, there is some technical debt we need to deal with, so the estimate of this feature is higher than it will be if we just add it.
But remembering that jump is close to 1.
Yeah?
When that ball uniform happens, is there a chance to solve this situation?
Yes. Yes, Scrum, especially Scrum, is also some kind of lean software development. So first of all, you need to generate the slack time for the paying back technical debt. It's the first step. I think it's the biggest advantage of Scrum, because you have this time box. Nobody should distract you, and you could plan what you will do during this sprint. No, it cannot be stopped, because I cannot imagine any business any product owner who will allow you to stop feature development. You still need to do feature development, but you need to introduce some changes, some refinement during these features. Sorry, I have quite time. Okay, so if you have any questions, I will be there in the next 10 minutes. So, thank you.